is a way of evaluating limits when the limit is of an indeterminate form. So first let's talk about what it means for a function or an expression to be in an indeterminate form. So indeterminate forms mean 0 over 0, infinity over infinity. These are indeterminate forms. Also, you can have exponential indeterminate forms, which would be like 0 to the 0. That's an indeterminate form. Infinity to the 0 power indeterminate form. 1 to the infinity. These are examples of an indeterminate forms. And also you can have indeterminate form when you subtract infinities from each other, because essentially you don't know which one's bigger than the other in that case. So all these things I just listed here are in indeterminate forms. So if you have to take the limit of something where when you try to use direct substitution and just plug in the value for x, you get one of these things, you're going to have to use some way to simplify the function. Now, in the case of the powers, you might have to use like an ln, or take the log of both, take the log of it and then do the e later. In the case of if you're subtracting there, you might need to find a common denominator or do the conjugate or something like that. Basically, your purpose is to get everything to be a fraction. So if it's one of these indeterminate forms, you want to use some algebra to get it to be a fraction. If it's one of these, it's already set for you, because you need to get it in a fraction to use L'Hopital's rule. So what L'Hopital's rule says is that if you take the limit as x approaches a of some rational function, so you have a numerator and denominator, if that limit is indeterminate, and it's important to note that this is only if this limit is indeterminate. If this limit is not indeterminate, doing L'Hopital's rule will get you the incorrect answer. So it has to be an indeterminate form. Then it implies that the limit that you're looking for is equal to the limit as if you had done the derivatives of the top and bottom. So if you have an indeterminate form that's a fraction, you can do the derivative of the top and the derivative of the bottom and see if that helps you, to see if it becomes something that you can get by using direct substitution or anything like that. And keep in mind, this is something you can do over and over. So if you find that your function is indeterminate, you do the derivative of the top and the bottom, you try it again, you get indeterminate again, you can do the derivative of the top and the bottom again, and continue on that path until you get to something that's not indeterminate. But like I said, if you get something that's not indeterminate, if you try to do L'Hopital's rule to that one more time, it will get you an incorrect answer. So you can only use this on limits that are indeterminate, and indeterminate forms look like that.